Like simplification?
Yeah,
Or-
this is very like algebra, if you will. And I don't get like how you can just drop off a P or T or something. 'Cause it doesn't just disappear.
Depends on the rule that I'm using. Like the last one, we ended up with distribution giving us that one line, right, which looked, whatever, P or T, and P or R, right? Like, we ended up with that because we started off with P or T and R, right?
Mhm.
So distribution allows us to bring this into this
Mhm.
this way, right?
Mhm.
And now simplification says I can just go away with it, do away, because if I have both of these, I have this one.
Mhm.
So simplification allows me to go like that, and this is gone.
Well, where does it go?
Oh, I still have it. Theoretically, of course, it's all of this information is still there for me to use. It's not like I'm going down the road and I have the choice of going this way or this way, so I go this way. Well, now I don't have that choice anymore. It's not like that, because I can use things from any of these lines at any point in my further steps. So that's why over here I'm writing from lines 1 and 2, modus ponens, whatever, from lines. But notice though, if it's any of the replacement rules, you only have one line in your justification. Is say I get this, I end up, and simplification, right? That's only one line. But some of them, you notice, like modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, constructive dilemma, all those require two lines in your justification to say, well, because not P or Q gives me if P, then Q. Implication, that's only one line. But if I have P or Q, not P, then what I end up with is Q. Well, to explain that, I can say disjunctive syllogism from these two lines. So what you're writing over here is giving you your justification for what happened there. So let's do number 8. Here it is. So number 8. Not the case S or Q. The conclusion is, if not the case P, then not the case S. So addition is definitely going to be part of what I do, because there's no P in this. So where does the P come from? It has to be addition. But not S. I need not S out of this. Well, this is just a single statement that says it's not the case that either S or Q. I can bring that negation sign in using De Morgan's and end up with not the case S and not the case Q. De Morgan's on line 1. Right? And since this is a conjunction that says I have not S and I have not Q, I can easily conclude I have not S by itself.
And the simplification.
Yep, simplification. On line 2. And now what I want to do is use addition to add what I need in order to get this. But let's think, what's going to be appropriate here? Because not S,
Not,
if that ends up going on the other side in implication, I'll lose the negation sign. But I want not S on this side. Well, maybe that's all right, as long as I can use transposition to switch them back again. So maybe that's what I need to do. But then what do I need in order to get this correct? I can try out several things, but my first thought is let's try P.
when doing addition, can you only add,
Or P.
you can only add P without the negation?
You could add P with the negation.
So we could just say not S and not P?
We could, but will that eventually give us what we need? Because if we just add P on 3, now I can use implication, and what that does is it changes this from either not S or P to if S, then P, right? Implication on 4. And now I can use transposition, which changes the P to not the case P, then not the case S, which is what we were looking for. Now see, if I had added not P, then implication would have given me if S then not P. Transposition would have given me if not P, then not S, which is not.
Gotcha. Okay.
So I gethunked a few steps ahead of myself. Gethunk is not correct German for fault.
Okay.
Gedacht would be correct. See, my mind is so muddled, I use the prefix ge. I kept thought, except I changed it to the incorrect thunk, which is not the past tense of English. So I ended up with gethunk, which is no language at all.
German.
That could be.
So when you went from 4 to 5, where did the or go?
Ah,
And the if not?
you mean this?
That and the or, where did they
Right.
go?
So implication says if it's actually P then Q, but if S then P, right, is equivalent to not the case S or P. Right?
Okay.
So, in this particular case, even though I said implication, implication goes either way. This is equivalent to this, and by the way, this is equivalent to this. So if I have this, I could put this in its place. So I had this there, but I wanted to go to this. So 4, using implication, is this.
Okay.
So where did they go? Well, the equivalent statement, you know, there's other things I could do. I could manipulate a lot of this stuff. It's amazing what these rules will allow us to do. But where did they go? Out into the ether? They're actually still here. Because this statement is equivalent to that. So the actual negation in front of the S is still there in the sense that I haven't changed the logic of what I said from the one statement to the other. And if we want, we could check this with truth tables, and you could see that, yes, in all the cases where these have truth values, in those same cases, this will have exactly the same truth value. There's no circumstance where these aren't exactly the same logical expression, even though they obviously don't look the same. It's kind of interesting to say that a lot of what we express in our everyday speech has logical implications that are hidden to us for the most part. We don't automatically think this way. Computers do, though.
Really?
Computers are just, all the code that computers are using is basically built off of symbolic logic. Didn't I say that at some point?
You probably did.
That's what Bertrand Russell was trying to improve our ability to communicate. Had no clue that eventually computers were going to be using his symbolic expressions.
Can't we just have truth tables for a test? I think that's a good plan.
You can do proofs with truth tables, but you'll find that they're huge when you start doing some of the more complex ones. Even these. But yes, you can actually use truth tables to do this. The idea of going to the propositional calculus, or whatever you want to call this, is to make it easier than truth tables. Truth tables be too long and complex. Remember, we started off by going to a shortened version of the truth table. But all that actually enabled you to do is demonstrate that a statement or a argument is invalid. It becomes much more complex when you're trying to show that it's valid. What we're trying to do here is to demonstrate that these are valid. And also sell logic books and have a job so that you can get paid for doing something that, as some people say, pulls the wool over everybody's eyes, because professors don't really know how to do anything. You've heard that, right? I think Dunleavy says that.
Didn't Dunleavy graduate from UAA?
With his master's degree in education.
Imagine that.
Yeah, this is his alma mater.
So on number 6, where did the if-nots come back in?
So here, notice I've transposed these.
Mm-hmm.
And transposition says this is equivalent to this. So in each of these steps, as we're changing things, we're transforming things in ways that are valid. In the case where it's a replacement rule, we're saying they're equivalent. So here and here, this is different, right? De Morgan's is a replacement rule. So here we're saying we're making an inference. That simplification allows me to say, I have not S if I had not S and not Q. Then I have this. Addition, oddly, says that it's still valid for me to just pull
Things out of thin air.
things out of thin air, as long as I say or. Because you have a yellow pencil, or you have a basketball. It's actually true because you have a yellow pencil. People that talk that way seem pretty weird to us, so usually they don't. But it is valid. You could actually say that. So how about 9? My hope, of course, is that as we do these, it makes sense eventually. I don't, at some point in my life, it made sense to me. I didn't teach logic in graduate school. I taught regular philosophy classes.
Are they different from this?
This is logic. Philosophy is very different. It's the history of thought.
The history of all
Socrates,
thought?
Yeah,
No way.
as much of it as you can remember anyway.
Is it interesting? It sounds interesting.
I think so.
You know what I find
It's the
interesting?
definition of interesting. But
When Raphael painted the, now I'm gonna forget what the heck it was he painted. The
School of
Pope.
Athens?
Yes. All of those people, philosophers. Well, most of them. Like
Well, that was
90%
on
of them.
one wall.
Right, there's 4 plus a ceiling. And then there's 4 different chambers. So it's 4 walls plus a ceiling.
He had a whole
Times
crew.
4.
He had a team.
He did.
He wasn't by himself.
And he didn't do one of the rooms, he died. Or
Oh, really?
somebody finished it. Yeah.
He was kind of what?
Slut.
Well, I mean, everyone in Italy who was rich was, right?
He wasn't rich.
He
He
wasn't
was
rich.
just a workman. They weren't
That doesn't
considered.
mean he wasn't rich. I
He
mean,
was
like,
rich.
well, I mean, he better off than the people at the time who were just drinking bread,
Well,
and
yeah, I suppose so.
eating bread and drinking like alcohol.
He was like kind of a nobody when he first started. Wasn't it Bernini that found him? No, that's not
Da
right.
Vinci was one of his mentors. The painting of the School of Athens, the portrait of Plato,
Right.
everyone agrees is actually Da Vinci.
I thought they fought though. They had like a rivalry. Like they did little digs to each other. Yeah, that's what we learned in my art history class.
Da Vinci was much older. Raphael was a kid, basically.
Right, he was like really resentful at Raphael for getting that project that he did. And so like to be a turd,
Da Vinci didn't like to paint though.
didn't
He only painted like 14 paintings.
ever.
And a lot of them he painted over and over and over. The Mona Lisa, that was like done 50 times. And he never quite finished, so it was the final painting. There's actually multiple copies, right? Because he painted, so there's same painting. There are differences, but yeah, the famous Spanish museum, what's it called? The it has its own, and the Louvre has a Mona Lisa that's like the famous one. But
Is that the one where all the
Spanish
Picassos are? Like Guernica, where Guernica is?
I think
I
so.
can't think of what that is called.
Like Guernica was in like a
Piazza.
specific place, but
Guernica is a place, but it was a painting done by Picasso because of World War II. The bombing of Guernica, and that's why he made the painting.
yeah, it's huge.
But anyway, that Raphael painting, there's only one girl in it. What's up with that?
She's not a girl. She's not a girl. The Pope is furious when he found out that there was a woman in that painting.
Right?
And so Raphael fixed it by saying, it's not a girl. Problem solved.
So
It
were
looked
they-
like a girl, and it was supposed to be Hypatia,
right.
but it's so-and-so. And then the Pope is, oh, okay.
So were there not very many women philosophers?
There were. They just shot them all.
That's terrible.
Oh my god.
Called him a witch. Murder! Murder! Sorry, that's Monty Python.
She's made of wood.
And she weighs the same as a duck. All right. Wait. So number 9. We didn't do 9. Not the case P and Q. If Q then, if R then, not the case of R. So this is pretty easy to get out here, right? First, we want to put the Q on this side. Or do we have to? We could simplify just from that, I guess. But that's me. I just like to do it step by step. And so I have the Q. Just comes right out. Because I have both. So I also have Q by itself.
It's simplification.
Simplification. Now that I have Q, I have modus ponens if R then P. And that comes from 2 and 6. Now, take out the not P, simplification from 1. This is if R then P, but not the case P, so modus tollens
Not the case R.
must be not the case R. Email me if you need to read the. So we want to get R or S. Actually, since addition will allow me, I just need one or the other, right? But what could I get out of here? Not the case P will give me not Q. Not Q will give me this. So not the case P, I'll just get not Q, that's modus tollens from 1 and 2. And not Q is the negation of this, so that means I have not P then R. And that's disjunctive syllogism from 3 and 4. Not P, and if not P, then R. Modus ponens gives me R. From 1 and 5. And so I can just add the S. In fact, there's no place where S would come from anyway, so obviously I'm just going to add S. So 11. So B or R. What's interesting to me is that we already have P or Q, right? And that will give me, if I had the P, I would have the B. And the Q will give me the R. So what I really want to do is take these two out and use constructive dilemma. Put them together. I don't need these. I could get rid of those. Have Q then R, simplification, from line 2. And I can have P then B, from line 3, simplification. And then I can conjoin the two of them with the P in the front. So if P then B, and if Q then R, and that's conjunction from 4 and 5. By the way, the numbers I've noticed, the sequence and your justifications, what the book uses is he uses them in sequence, regardless of the order of the actual step. So in this one, for example, you might say, well, I actually used 5 and 4, the way I can join them, right? but he, in the book, just keeps using them with the lowest number first. So that's why if you felt like it was confusing, but it really isn't. As long as you have the correct lines in whatever order, it's okay. And now, since I have P or Q, which is there, P or Q, I end up with B or R,
It's a constructive dilemma.
constructive dilemma. And we did that with 6 and 1. Problem 12. Q. So not P is what I want to get. Here's P right here. I could get not P if I get not the case Q and R. So how can I get that? Well, here I have if R then Q. So that's these two. So we have to transform this to make it look like this, right? And what's kind of interesting is the first step, if we use implication, you end up with not the case R or Q, which is not really what we have there, but still, implication 1, 2. Well, another possibility is transportation. Let's use transportation, and I get not the case Q, then not the case R. It's transposition on 2. Will that help? Well, use implication on this, and I get not the case Q, or not the case R. Implication on 4. Which, just for fun, I could say that equals Q or not the case R, double negation. Look at that. Now I have Q or not R, but I also have not the case R or Q. So that's kind of interesting, since that means I end up with not R, even if I have Q or not. Wait a minute. both.
Could we have done distribution instead?
Ooh. Distribution or exportation.
Well, you can-
Oh, but that only goes when there's a conditional statement over here.
Which one?
Oh.
Exportation or distribution?
So maybe if we transform one, we can do that. Let's try that. 7, we'll go not the case P, or not the case Q and R. And that's implication on 1. And then I can use distribution here, right, to get not the case P or not the case Q, and not the case P or R. And that's distribution on 7. But here's what we want. But it's not free, it's attached to not the case P.
Why do we want the Q?
Oh, actually, we want not the case P, that's right.
So then, no, not simplification. What the hell is that?
Not the
No,
case
it's
P.
not constructive dilemma. Can we do constructive dilemma? Is that dumb? No, that's not right. Never mind. Disjunctive syllogism?
I don't see where we could do that.
I'm so friggin' lost. Not the case P.
Q or not R? Seems like we ought to be able to change that to get that. Well, we're still looking for that.
De Morgan's? On number 8?
De Morgan's on this. Let's see what that would do. I used De Morgan's on this. But let's, so first, I'm going to put the Q on this side, or not R. So that's just commutation on 3. And if I put a double negation sign out in front of all of this, it's double negation on 9. So that's equivalent. Now I can take one of those negation signs and move it in with De Morgan, so I'll leave the one out on the outside. And then one moves in, and I get not Q and not R. De Morgan's on 10. It's the negation of this except for this. Let me fix it. Not the case. Not the case Q and R. And that's double negation on 11. And so now I have the negation of this, which gives me modus tollens, not P. So a lot of these were a waste. But it didn't hurt. We solved it. That was problem 12. 13. P, then Q and R. And if S, then L and Q. T and R. Then Q and R or L. Or L. Or L. So what we want to get is Q and R or L. Have Q in a few places. Have R, have L, I have P, and I have R. So if I take this out, and I have P, I'll have Q and R. So let's do that first. Just take out P, simplification from line 2, and 4, I'll have P, then Q and R, simplification from line 1. If P, then Q and R, but I have P, so Q and R. That's modus ponens from 3 and 4.
Do you,
I'm not sure if you could just add L to this, because you'd end up with that.
oh, but then we could move it using?
No, we couldn't.
We can't?
Well, we could use
What's that one word?
distribution and get L
Yeah.
and Q and L and R, but that's a lot of extra steps. Let me instead.
No, what about association?
We have R all by itself, so let's just take R out of there. Oh wait, I wanted Q and R. What happened? We needed that. Modus ponens. Number 3. But what do I want next? I want R out of there. Let's just take R, get it in either place, and then simplification from 2. And I'll add L to R by itself. That's addition on line 6. And now, oh, I didn't get Q by itself. Let's get Q by itself. 5, simplification. And now I'll add Q and this. And that's just conjunction. 8 and 7. Email me stuff?
Yes.
So 14. Not the case P, then Q or R. That's all I needed for and the conclusion is so if not the case P, then Q or the conclusion is not the case P and not the case Q, then R. What do we do to transform this? Put double negation on Q.
Why would you put a double negation on there?
Because now I can use implication. Implication requires a negation sign. It goes not the case P or Q. It's equivalent to if P then Q. Right? And so I need a negation sign to do that. So now I have P, then if not the case Q, then R. Implication, right? I went from the reason I did that was I'm thinking I can go, if not the case P, and not the case Q, then R, and that is exportation, right? Right, exportation. Exportation says, if P then, if Q then R, so if P then, if Q then R, becomes the conjunction of if P and Q then R. Although in this case I've got the negation signs. Heading Gallant. What time is it? 8:30. Well, you're welcome to leave. of
I
course.
didn't wanna be rude and,
Walking from.
yeah. I was leading.
That's okay. That's so you can make sure you follow the rest of it.
I mean, I'm not saying, but I'm saying. Have
Yeah.
a good evening, you guys.
Hasta luego, пока, до свидания, sayonara, cheers, ciao.
That was a pretty short.
Which was, oh, that one? Depends on how much protein I had in my brain. Could be too that sometimes I don't pick up the easy way to do them. There are multiple ways of doing some of these. I think there are multiple ways to do all of them, but I'm not sure. So. P then Q and R. Would any of you like to do these? Come up and do some.
I'm still confused.
Onward. Which number are we doing? 15.
But I missed the class that you went over this, so that's my fault, but I had major mouth surgery, and I was
Yeah.
like dripping
Oh,
blood, and
Yeah.
I couldn't move my face, so I stayed home.
That's a pretty good excuse.
Pretty legit, right?
Very.
Seems pretty
I
legit.
lost my wisdom teeth when I was at the Defense Language Institute.
Mm-hmm.
And the course had already been started, we were there, and I remember that was the week after I had my teeth out. And I came in and I had cotton stuck in both sides. And Mr. Lapellis looked at me and said, "Здравствуйте." I couldn't do it. And he marked me down, because my pronunciation wasn't any good that week.
Really?
Yeah. It was totally unfair. And I told him I had good teeth out. Didn't change his mind.
Yeah.
Russians, you know, oh, you either get it right or you're wrong. No excuse.
I tried to convince my dentist that he was just seeing things on the x-rays that it wasn't necessary. I had 3 rounds in 1
I'm
week,
convinced
and we're not
that
done
they
yet.
just like doing that. They think it's fun.
Yeah, but they have nitrous
Tear
now.
your face apart.
The VA has nitrous now, so I'm like, do whatever you want.
Yeah, but they,
I don't
if you
care.
ever saw videos, they stand on your chest with a sledgehammer and boom.
I had an extrication that was very similar to that. If the dentist really insists that you have IV sedation, you should probably listen to that. And I didn't. Because no, the gas will be fine. It's horrible.
Totally different end of the spectrum.
It's
But the
horrible.
last time I had my colonoscopy,
Mhm.
they said you should have, you know,
IV sedation.
sedation. Yeah.
Mhm. Yeah, you want sedation.
And I was like, well, but see, the thing was, if I had sedation, then my wife would have, someone else would have to drive me home.
Mhm.
So my wife would have to drive. Well, but my wife hates driving. Plus, it was early in the morning, and my wife doesn't wake up usually until way late. So I figured, okay, well, she can come, because I have to have someone. But I'd rather not have the sedation, so that I will still be able to drive home, right?
How was that?
You know what?
Kind of like a root canal without
That was
Novocaine,
like-
yeah?
So painful, I can't believe it. And what do you do? And I'm like, so, give me morphine, or whatever, you know, whatever the appropriate, you know. So they did, but by the time I was, you know, the worst of it was. So, my wife drove home.
Did you have a donut
That was-
that you sat on?
No. No, there was no, actually, I'm still not sure, that was a long time ago. I think, and they do that, they're so rough, I think some of the stuff gets knocked around. I mean, I wouldn't be surprised if I could become pregnant now.
You watch Lifetime?
You okay?
Oh my god, he's killing me.
You mean I could have actually done stand-up, and I could have,
That was really
I could have made money for that?
Yeah, you still can, man.
Come to think of it, I did make money for that. 'Cause you guys are paying my wife, so.
Paying your wife.
Well, she gets the money.
For now, we'll see.
Yeah, yeah. Okay. The problem
Sorry,
is-
I didn't mean to take us off course, but you looked at me when you asked if anybody wanted to do this. And I'm
do-
catching up,
Good.
trying to catch up. Some of it makes sense.
Ketchup is my favorite condiment. So,
Yeah.
It is really great.
it is.
I had my mom mail me ketchup from back home because it's so good.
Really?
I kid you not. I'm like, Mom, I need more ketchup.
Is it like homemade or is it just?
No, it's this,
Like no
it's, Wegmans is a chain of grocery stores in the Northeast, and it's Wegmans organic ketchup, and it's the best ketchup you've ever had. And now, my friend that lives across the street, he's like, is your mom gonna send more of that ketchup? So now she's mailing ketchup to 2 people.
You should start up a distribution center.
I should, it's good stuff.
Get everyone hooked on that shit.
Wegmans organic ketchup. Can you get it on Amazon?
You know, watch you.
I don't know,
You end up discovering that they've got pot in it or something.
Awesome.
maybe. Maybe
Awesome.
that's why it makes you happy.
Makes you happy. Wasn't there Coke and Coca-Cola? Wasn't that a thing?
At
Oh,
one
yes.
point, yeah.
That was the.
And what
Well,
did they
then,
put in 7-Up? They put
They put
something
stuff
in
in
7-Up,
7-Up?
hence the up. Yeah, in the very beginnings, they put something in there.
I wouldn't be surprised. Freud was the one that got Europe addicted to opium. Or or cocaine, whatever, whichever one.
He did blow, didn't he?
Yeah, he ended up with cancer of the mouth himself, but I think that was from the cigars. But it really did help with psychoses, I guess.
That guy's insane.
What? Cigarettes or
No, cocaine
cocaine?
or
I mean,
whatever
possibly.
it was, whatever he
Possibly.
used.
I mean, we use Adderall.
Must work 15. FP then, Q and R. Line 2 is if Q then not R. And so, if P then S. So, so if P then S we want to get, here's if P, no S. So clearly I'm going to end up with addition. But I also will need not the case P to get this, right? Because I'll end up getting this. This will be, I'll assume it'll be P then S. That'll be my last line. And the one before that will be not the case P or S. And this will be addition to get this one. And so I'll have to get not the case P. And I can get not the case P if I get not the case Q and R. So let's see if this is equivalent to not the case Q and R. So how can I change this? Not the case Q or not the case R is implication on 2. So if P then Q, but either not the case P or Q, so leave this the same, but this gets a negation sign, and this changes to a disjunct. So now that I have this, that becomes not the case Q and R through De Morgan's on 3. So there's my not the case Q and R. So 5, not the case P, and that's modus tollens from line 1 and 4. And then line 6 is addition to 5. And line 7 is implication on line 6. Wait, notice that's something you can do too, is you can work backwards from the conclusion sometimes. If working forwards doesn't make sense, you can start backwards, and as you're working backwards, come to a point hopefully where you see, aha, so now I know what I need to do in order to connect them.
How on earth did you go not the case Q and R down to not the case P?
So not the case Q and R is the negation of this,
Mm-hmm.
and this is if P then Q or whatever, right? But if not the case Q, then not the case P. So that's modus tollens. Remember, modus tollens goes if P then Q, but not the case Q, therefore not the case P, modus tollens, right? And in this particular, remember these are variables standing for whatever, right? So in this particular case, I'm looking at If this, then that, but not this, so not that. So modus tollens. Remember each of these inference rules and the replacement rules, what you're remembering is the thought patterns that are equivalent or that give you inferences that are valid, right? And that's why we're doing more and more complex things like this, so that they let you see that point, that modus tollens doesn't always just look like if P then Q, not the case Q, therefore not the case P. It can look like this. Thanks. It's helpful. Come back. I mean for you to go to.
Use the force.
It was way overkill. 16. If T, then R and S. If R, then S and P. So therefore, P or not T or Q.
3, 4, 36.
T then R and S. R then S and P. Ooh, if S then P. Ooh. And then P or not T. Ooh, or Q. We've got this. P or not T. Phew. So P or not T or Q.
Wait, how did you get that?
Isn't this what, does that not look right?
No, I'm just, how did it get that?
That's the question.
Oh, that's the question.
Yeah, how did we get, how out of this
Did we
do you get this? So, let's see, here's a P. I don't see Q at all, so Q
Yeah.
is just, so that's addition.
Okay, okay.
P or not T, well, here's T, here's P. Here's, okay, so I've got R and S here, so I'm looking at like kind of a hypothetical syllogism that if T then R and S, then P. So how do I get the R and S to look, how do I get these to look like this, right?
Okay.
And I know if R then, if S then P, that's equivalent to R and S then P, and that's exportation on 2. And so I have if T then P, hypothetical syllogism between 1 and 3, right? So if T then R and S, if R and S then P, so if T then P, hypothetical syllogism. And if T then P is let's use implication first. We have either not T or P, it's equivalent to that. And to this, I want to, well, I could commute this, or just go ahead and add the Q and then commute it, but I'll do the P or not T. And that's just commutation, swap them. And now, I already put the parentheses there, but it's not necessary there. But now I need it. Or Q. Just addition. 6. We're almost getting to the test portion. 17. Goes, if not the case P and Q, then R or S. Not the case, P and Q, then RS. 2, not the case P or not the case Q. T. T and R, or T and S. Well, if we get T and R, we could just add T and S.
No, 3 is T.
Well, we can't just invent R. We can't just invent S. So we have to get either R or S out of there. In fact, if we get R or S, we might be able to put that together. Let's see. So what can we get out of the rest of this stuff? Well, we have not the case P or not the case Q. That's this. We just have to remember to apply De Morgan's to it, and it becomes not the case P and Q. De Morgan's on 2. And so we have 5 R or S modus ponens 1 and 4. Right? Because if this, then this. Well, we do have this. So we have R or S. So R or S, and we have T. So we can then add T and R or S together, conjunction. And that's 3 and 5. And then we could use distribution.
This is.
Well, in distribution, we have P and Q or R is equivalent to P and Q or P and R, right? So this is equivalent to this. So we go T and R or T and S. And that's distribution on 6. So I'm going to skip 18. But I'll go to 19. You notice that they've gotten more difficult as we go. So 19. Number 1, if P, then Q or R. S, then not the case Q or R. So therefore, not the case P and S. It makes sense, because of course, not the case P and S means I don't have both P and S. Because if I had S, then I would have not the case Q or R. But if I have P, I have the case Q or R. And that's opposite. So if this, then not that. And if this, then not that, which would give me not the case P and S. But let's see, how would we do it? So we're going to have to get rid of the conditional statement. So the first one can become not the case P or Q or R. Implication on 1. And 4 will give us not the case S or not the case Q or R. Implication on 2. Thinking I can combine them, but the thing is, these are the negation of one another. So that won't work.
Is there a D&E? Not true.
let's move this in here and see what happens. Not S or, De Morgan's on this will be not Q and not R. It's De Morgan's on 4. If I look at distribution, and I have P or Q and R, that's equivalent to P or Q and P or R. And in this case, not the case S, or not the case Q. And that's distribution. Second version. 5. Now I can take this one out. Be the most useful. Simplification. 6. Can I do the same thing here? What would happen if I did that? Let's see. Not the case P. Oh, but that's a disjunct, so that doesn't work. I can't use the same thing. Unless let's see. If P then Q or R. Aha. This is interesting. Let's try. You can try whatever you like, by the way. I'm up here trying to puzzle this out, and I'm wondering if I use transportation on this one and end up with not the case Q or R, then not the case P. Transposition on 1. So now I have not the case Q or R, not the case Q or R. If S, then not the case Q or R, then not P. So if S, then not P, hypothetical syllogism. You see how that works? If S, then not the case Q or R. If not the case Q or R, then not P. So if S, then not P, hypothetical syllogism on 2 and 8. If S then not P, put implication on that, I get not the case S or not the case P. Implication on 9. Step 11. Let's switch them so that I have not the case P or not the case S. It's just commutation on 10. And now I can use De Morgan's to change this to that. Shoo. They are getting tougher. I'm going to switch to red. Do you think red will work?
I have a question.
Yes.
For number 10, could that one have just gone straight to the Morgans instead of using a computation or no?
It could, but, and what it would have been then, instead of, not the case P and S, it would have been not the case S and P, and then you could use commutation there,
Okay.
because you want it to look just like the conclusion. Oh, 20 is one of the ones listed in the test, so I'll go to 21.
It's not listed on the test.
Pardon? It's not? Oh, okay, let's do it. No, I'll do 21. Remember, stick to the odds instead of the evens, and that way I don't overlap the, so let's do 21. Either P or Q or not R. Either P or Q or not R. If P or Q, then Q. And if not R, then S. Three, not the case P. So Q or S and not R. So Q or, so I can add whatever I want. So if I get Q, or if I get S and not R, I could just add the other. Can I get Q out of here? Well, here's Q, couple places where Q is. So let's see, not the case P. So let's take this P or Q, then Q out of here. That's simplification. Out of 2. And I can add Q to this. Just addition. 1, 3, what I need. That might not be helpful. What if I added not Q? That would give me not P and Q. But that doesn't. How about constructive dilemma? I have a disjunct here, and I have 2 conditional statements all together. This is the antecedent here, so, and not R, it's the antecedent here. So constructive dilemma. Natasha would have, constructive dilemma, she would have built it. So, with this and this, we end up with Q or S. Right, because the P or Q gives us this part, and the not R gives us that part. So we end up with Q or S, constructive dilemma, from lines 1 and 2. So Q or S.
P or Q. If P or Q, then Q. Not P or not Q. Q or S. Constructive dilemma.
Right, so I didn't do anything with this, and I didn't do anything with this. I was getting nowhere as far as I could tell. And I looked back at this and I realized, hey, constructive dilemma
Okay.
pulls this out. But now, can I transform this somehow into this? I don't think so, because I can't add stuff to it.
We can take away, so maybe disjunctive syllogism.
Well, I would need not the case Q or not the case S by itself, and I don't have it. But I do have this. And R and S are what we have here. We also have the not R up there, but let's take this out of here. Not R, then S, and that's simplification from line 2. And what can I do to this? I can go not the case R, or S. Implication on 7, which is really R or S. And if I add this and this, I end up with Q or S, and not the case R or S, conjunction. Eight and 6. What I'm thinking is the S is doubled here, so maybe I can combine them to get the S in one spot and then drop the one side, so that I end up with Q or S and not. But how do I get not R instead of not R? So if I combine them, I've got to get the S on the same side. So what I'm looking at is distribution. It would be the bottom one going from the right side to the left side to get S. But how's that going to help? Could get Q over there, but I have Q only once, so I wouldn't be getting rid of Q.